Here, I just took the bar with one.
All right, it's 7 o'clock. Let's go ahead and get started. Can everyone hear me on Zoom? I see the microphone going, but just I always check just to make sure. Maybe I should have done mic check before the class started. All right, thank you, everyone. Okay, good, awesome. All right, so welcome to EGME 520, everyone. I'm your instructor, Professor Justin Tran. So it's my first time in this building, first time in this classroom. I'm not used to the ceiling being so close to my head. If you've ever been in the engineering school, the ceilings are a little bit higher. So, I guess this is what tall people must feel like. It's kind of nice. Okay, so today's our first day. So usually for the first day, I'd like to just give just some introductory lecture slides, nothing too heavy. But today I am actually going to lecture a little bit too, just because this semester we do have a lot of holidays on Mondays and Wednesdays this semester, so we're actually losing out on a full week. And so any time that we do have together, I'm going to make as much use of it as possible. So plan for today is first half we'll go over the slides. It's not too many slides. It's mostly just syllabus and taking a tour of the course website. Then we'll talk a bit more about what this course is about. Okay. All right, and if you have any questions throughout today, definitely feel free to raise your hand. Yeah, let's go and get started. Okay. All right, so a little bit about myself. So my name, again, is Professor Justin Tram. So these are just ways to contact me. So my office is in the engineering building. So that's over in the engineering quad. That is E220. So if you take the elevator up to the second floor, you just turn right, and you just keep going down the hallways and keep turning right. My office is right at the corner. My email address, which is my preferred way that you contact me, is justran@fullerton.edu. And so, you feel free to send me an email anytime. I know that Canvas also has this messaging feature. So, I won't get mad if you message me on that, but I do prefer email just because I do prefer all of my communication to be in one place. So I grew up here, so I've basically been in Southern California almost my entire life, with the exception of grad school. So I grew up in Cypress, and so if you don't know where that is, that's just 10 miles west on the 91 from here. So I'm very familiar with this area. I had a lot of friends that came to Cal State Fullerton, so very happy to work here. All of my education has been in mechanical engineering through all different parts of California. My bachelor's was at UCLA, my master's at UCSD, my PhD was at Stanford. So mechanical engineering has kind of always been my home department. And in terms of my research interests, I kind of operate more in kind of the space in between mechanical and bioengineering. And so a lot of my past work has been, applying engineering tools for studying heart and blood disease, specifically running flow simulations of blood. And so this class is actually pretty important to a lot of what I do in research, at least from the conceptual point of view. And I'm also interested in STEM education. So, just being an instructor in the STEM field for the past 7 years, I'm always interested in different ways that we can, do this a little bit better. Okay. All right, so next let's talk about learning objectives. And so, I do see some familiar faces here. So, I know probably a lot of you know how I operate, but, what I always like to do at the beginning of class is I like to show my learning objectives for the day. So you can think of these as kind of an outline in terms of, or like a little bit of a preview in terms of what to expect from the lecture that day. But I write them very intentionally. So, if you kind of read my learning objectives, you'll see that all of them start with the verb. And that's very intentional. And so the reason for that is I want to describe to you, some type of skill or some way that you can demonstrate your learning at the conclusion of the class. And so what I always encourage people to do, because I'll usually have these up before the class starts, is, write these down in your notes and kind of use them as a way to organize your notes and organize your study. Okay. So today, we're just going over just an introduction to the class. We'll talk about what viscous fluid flow actually means and what context, we actually use that for from an engineering perspective. And then we're going to go over just some of the logistics of the class in terms of office hours, syllabus, things like that. Okay. All right. So let's start talking about the class. So, probably you guys have guessed just by signing up for this class, but, EGME 520 at its core is a fluid mechanics class. So, I think, probably everyone here has taken a fluid mechanics class at some point just because it's a prerequisite for the course. But just to refresh your memory, fluid mechanics is the field of study that is concerned with moving and stationary fluids, okay? Which, have a lot of applications. And so we have applications in transportation, power generation, materials processing, manufacturing, food production, civil infrastructure, just to name a few. And there's, a lot more niche applications beyond that as well. Okay. So I think probably what everyone has taken here has just been an introductory fluids class, where you kind of do a survey of everything that's involved. Well, not everything, but, general survey of, most of the most important topics are fluids. Okay. Now, with this being a graduate level course, of course, it's going to be a lot more specialized and a lot more in depth. And so viscous flow, which is the subject for this class, is a subset of fluid mechanics where we are going to be looking at specific situations where viscous effects are important, okay? So I think hopefully everyone here is familiar with the concept of viscosity. Viscosity is the property of a fluid that describes its resistance to flowing, right? So every fluid has a viscosity the same way that it has a density. And so some fluids are very resistant to flowing. So think of things like honey or molasses. So those are kind of very hard to get going. But then you have fluids that have very low viscosities like air or water, where they almost don't resist at all. And so you just tip them a little bit and then they just go flowing. Okay. And so generally, viscous effects are going to be important when the flows are relatively slow. Okay. So we're not going to be looking at turbulent flows. We're not going to be looking at high-speed flows that you would typically see in an aerospace application. We're going to be looking at flows in relatively small spaces. So think of things like, the flow of blood inside a blood vessel, or maybe the flow of water inside a very small pipe. Okay. Or we're going to be looking at situations where the flow has very high viscosity. Okay. So there's a lot of really important engineering applications for this. Which you might read that and think that seems very limiting in terms of the situations that we can look at, but there are a lot of applications that you'll see, right? So the whole field of lubrication, for instance, right? So the fact of whenever you have moving mechanical parts, oftentimes you add some kind of grease or oil to kind of help the parts move, right? That's a very classical application for viscous flow, right? Because you have a very small amount of fluid that's kind of operating in a very small space, right? And lubrication theory is something that we're going to be going over in this class. Okay, so let's go over a few more applications. And so, for instance, flow in a pipe is a very classical situation of a viscous fluid flow. And so, what happens when you have flow in a pipe is, you have flow that's contained between these two walls. You have, very kind of small amount of space. You have boundary layers that develop and kind of merge, and you get a velocity profile that's dominated by the viscous effects. Okay, so we'll be talking about pipe flow a lot in this class. Okay. Another area where viscous effects are important are in boundary layers. So boundary layers are these thin layers of fluid that form, at the kind of right next to a solid surface. And so even if you have a very turbulent flow, even if you have kind of a very external flow, there's always this kind of thin boundary layer of fluid where viscous effects are going to be important. Okay. And boundary layer production, I know I just finished saying that, viscous effects aren't that important for aerospace applications. Boundary layers actually are, right? And so, we're going to spend quite a bit of time talking about boundary layers in this class as well. Right, so I just finished talking about lubrication, right? So lubrication, very important for engineering applications. You can think of very many applications of lubrication, right? The idea between lubrication is that you have this very thin layer of fluid that exists between two solid surfaces to cut down on the friction between them. Right, and so that's a very classical viscous flow situation. Okay. Okay. And so those are just a very quick overview of some of the applications that we'll see in this class. Here you're looking at kind of an overall kind of view of the overall topics that we're going to cover in this class. Okay. So you see some familiar faces here. So it's boundary layers, lubrication, conservation laws, things like that. And we can even expand this further for all the smaller topics as well. Okay. Now, I used to love these kind of bubble charts, but I realized that at the beginning of the semester where we haven't learned anything yet, a chart like this is meaningless. But I think probably as we go throughout the semester and as we kind of learn these different topics, what I'm hope that you guys will be able to do is, especially since this is a graduate level course, is that you'll be able to form connections between all these different types of topics that we're going to be looking at, okay? Because it's not just it's not just a bunch of topics that we've kind of strung together that have nothing to do with each other, right? A subject like fluid mechanics is very much interconnected, where one topic really kind of feeds into and builds onto another topic, okay? And you have this kind of very complex web of connectivity in between the different topics that we're going to cover, okay? So that's kind of what all the arrows that you're seeing in this chart is. Okay. Okay. All right. So I know that went really quick, but I did want to get to some of the lecture today. Any questions on just the very brief introduction to the class? Okay. I will we'll do a bit more in the lecture, and I have a bit more detail. But usually the slides are on day one, and the lectures on day two. But again, kind of with the schedule we have this semester, we're kind of doing both on the same day. Okay. All right. So let's take a break and let's talk about syllabus, right? So course policies, office hours, things like that. So all of this information can be found on the course website on Canvas. And so I think I sent a link to everyone to the Canvas site earlier today. And so we'll take a tour of the Canvas site as well, but we'll go over it together here too. Okay, so let's talk office hours first. And so my office again is in E220, which is second floor of the engineering building. And so during office hours, my door will be open, and so you're free to come in. But I also have a Zoom option as well. And so if you can't make it to campus during the office hour times, you can join via Zoom, right? And so, if you've had me before, you kind of know how I work with office hours. I'm going to just sit in my office, I work on stuff. And if someone pops into the Zoom room or they walk into my office, then we can chat at that time. Okay. Good thing for you guys this semester is that the office hour times, I think, are a little bit more convenient for grad students, although if you're taking class during that time, maybe it's not convenient. But my main office hours are going to be Mondays and Wednesdays before the lectures, so 5:30 to 6:30 p.m. And I also have one office hours on Thursday afternoons as well, so 1 to 2 p.m. Okay. And of course, if you can't make it to these office hours, just because I know as grad students, your guys' time is very limited. I know a lot of you guys are working, a lot of you guys are working on research on campus. And so if you can't make it to the office hours, but if you do want to talk to me, just send me an email, and then I'm happy to set up like a Zoom time or a time that we can meet in my office for us to talk about the class or anything else. Okay. So office hours typically are for discussing points of confusion about the course content. And so if you have a question about the lecture that we just went over the previous day, or you have a question on the homework, if you have questions about an exam that's coming up, definitely feel free to drop by. Or if you just want to stop by and chat and introduce yourself, that's good too. So a lot of times I'm sitting in my office, so I'm usually working on other stuff, but anytime you want to drop by and just chat, I'm always open to it. Okay, course learning objectives. And so I really like my learning objectives. And so, on the one hand, we have our daily learning objectives that you'll see kind of on the daily here, but I also have course level learning objectives that kind of organize the course as a whole, right? And so I use these 4 learning objectives just to make sure that by the time we finish this class, you'll be able to kind of, do these things and kind of use them to demonstrate your work. Okay. Now, some of these may not make any sense now, again, just because we're at the beginning of the course. But what I hope is that by the end of the course, you'll look back at these course level learning objectives and say that, yes, I can do all these things. Okay. Right. So the reason I show this is just to show you that I'm not just doing random stuff. There is some thought to how I'm organizing the course, and this is kind of the way that I do it. Okay. All right, so let's talk deliverables. So this class will have 7 homework assignments, right? So that's not including the introduction. So that's 7 problem sets that you are going to be doing. There'll be 2 midterm exams and 1 final exam. So this class, is very traditional in the sense in that, it's a very exam-based class. Yeah, just because this class is just kind of theory heavy and there's not much application in terms of what we're doing here. Okay. So among those 7 homework assignments, I will drop the lowest one, right? And so that's kind of a policy I always have. So that hopefully takes some pressure off, just because I know you guys get really busy with your classes and with work and with other stuff. And so this at least kind of gives you a little bit of leeway where you can maybe miss a homework assignment or turn it in late and not feel like you're missing a ton of points. But please do them all, right? And so I write these homework assignments not to give you guys busy work, but because they are all meant to kind of complement what we're doing in the class, and I think more importantly, they're meant to prepare you for the exams, right? So I write all my problems. So I write all the homework problems. I write all the exam problems. I don't take anything from the book. And if I do, I usually modify it, myself. And so, I always tell people, if you can do the homework problems and you kind of really understand them kind of front to back, that's kind of really your best preparation for the exam. Okay. Another thing for this class is that, since this is a graduate level course, you guys are all adults. I know undergrads, technically they're adults too, but you guys are more adults than undergraduates. And so, I'm not going to go through and kind of, nitpick your homeworks and grade it for correctness. So all the homeworks in this class will be graded based on completion. And so what that means is that, when I go to grade your homeworks, I'll be reading it. And so it's not like I'm just kind of skimming through it. But, I may not be as, I may not go through it and leave comments like I would for an undergraduate course. Okay. And so, when I do finish grading and, every time I do, I do post the solutions, it is your responsibility to go check the solutions just to make sure that, you are kind of understanding everything. Okay. And sometimes I still will leave some comments. And so if there's something that kind of stands out to me with your homework responses, I'm not going to mark you down on it just because, I'm saying here that I'm marking for completion. But, if I can give you some feedback, just to kind of help steer you in the right direction or to help you kind of understand a concept that it seems like you're struggling with, I will leave those comments. But, grading wise, I'm just going to grade it on completion. Okay. All right, midterms. So among the two midterms, they are not going to be cumulative. And so what that means that midterm 2 you'll not need stuff for midterm 1 on midterm 2, but the final exam will be cumulative. Okay, so final exam will include stuff from the entire class. It may not be, it's probably not going to be absolutely everything. Part of the reason why you'll see soon, but you will be expected to kind of recall stuff from the first midterm. Okay. Dates for the exams I have listed here. So midterm 1 is planned for Wednesday, October 7th. Midterm 2 is planned for Wednesday, November 11th. So both of those will be in class. Okay. Final exam. So I know this class, we do have a final exam time during finals week. I unfortunately will be traveling during finals week to go to a conference, and so I will not be here. So our final exam will actually be in week 16. So final exam will be Wednesday, December 9th, which is technically our last day of instruction in the semester. Okay. And that's a typo. I'm sorry. So I'm not going to force you guys to stay here late. The week 16 final will be 7 p.m. to 8:15 p.m. So it'll be a normal lecture exam. Okay. That also means final exam will be shorter, right? And so, normally for a 2-hour exam, I can usually ask an extra question, but, because it's a week 16 final, we don't have that extra 45 minutes. I am going to shorten the exam. Okay. And so, during finals week, I know we have the time here, but don't show up. There will be literally nothing for you to do. And I'll probably be on a plane during that time. Okay. All right. Any questions on the deliverables for the class? Okay. All right, grades. And so I think the grade breakdown for this class is pretty straightforward. So homeworks will be 10%. The two midterms together will be 50%. So the way I break it down is, between the two midterms, whichever one you score higher on, I'm going to make that a higher percentage of your grade. So that'll be worth 30%. And whichever midterm you score lower in, I'm going to make it worth only 20% of the grade. Okay. Again, just to kind of give you guys a little bit of flexibility, just because I know, just things happen during the semester and you just, may not be able to find time to study for every single exam, or, maybe you're feeling sick one day. So this gives you a little bit of kind of flexibility. Also, if let's say you do really well on the first exam, you can kind of think of it as kind of reassurance that, you have 30% of your grade locked in. But if you don't do well, you can kind of make up for it on the next exam. Okay. I'm sorry, that's a typo again, so I apologize. I didn't get a chance to proofread this that much. We don't have a final project, we have a final exam. So final exam will be worth 40% of the grade. Okay. Last homework, may require some coding. And so I'm still kind of thinking about that kind of with our the fact that we're ending in week 16, we may not have time for it. But if the last homework, if we do kind of get to what I want to do, it will be kind of a small coding project. And so it'll be worth a little bit more points, but we may not get there kind of with the accelerated schedule, just because we're missing 2 lecture days because of holidays, and technically we're missing the last day because of the exam. So we may not have time, because I usually don't like to just throw a coding project onto you guys, just because I know kind of everyone's in different places with their coding skills. And so if we don't have time to kind of go over the coding, then last homework would just be a standard problems. Okay, letter grades. And so the breakdown of letter grades, I think here is pretty standard as well. So 90% and above are A's, 80% and above are B's, 70% above are C's, 16% above are D's. Okay, so that's pretty standard. And one thing I do at the end of the semester, so I know that as grad students, you guys have a little bit stricter grade requirements, and so I know you guys are required to maintain a 3.0 GPA. And so what I'll do at the end of the semester is that I will scale the grades favorably in your guys' favor if the class average is below a B minus. So usually, and especially for this class, just because this class tends to be a bit difficult, usually what I'll do at the end of the semester, I'll add, let's say all the grades are in, final exams, everything. The overall class average ends up being like a 77%. I'll probably add 5-6 points to everyone's grade until the class average is at that B minus level. Just so that, just to kind of help you guys out. Okay. But I don't do that until the end of the semester, right? And so I usually get these questions kind of after the midterm exams, but I usually don't do this until the very end. Okay. And usually historically for this class, it's been a while since I've taught this class, but I remember last time I taught this class, it was even pre-COVID, had it about 5 to 6% to everyone's grade. Okay. All right. Any questions on grading policy? Okay, textbooks. So there is, I would say, one main textbook for this class, and then one that we're also going to use for reference. So the textbook is kind of, I like to think of as kind of the grown-up version of the fluid mechanics textbook. So it's the Kundu book. So it's Kundu Fluid Mechanics 5th edition. So the version I have is 2011, just because I realize I'm getting old. That's the version I have from grad school. But I think they've probably come out with newer versions since then. And another book that is quite advanced, but also very thorough and very good, is White's textbook called Viscous Fluid Flow, which is kind of right on the nose for this class. So that book is fantastic. It's actually not that big, but it is very advanced. And so usually what I recommend for students that if you are going to pick one up, the Kundu book is a little bit, I would say, a little bit more digestible. The White textbook is nice if you're going to end up doing research involving viscous flow. But maybe not the best resource for this class. Okay. So with that said, I do post everything that you need for this class, and so my lecture notes, they do follow the Kundu book a bit closely. So I designed the class so that you can just follow my lecture notes. I post the full problem statements for the homeworks, and so you don't need the textbook for that. So if you do pick up the textbook, it really is just for your own reference. But these two are very good, right? As someone who kind of does his research in fluid mechanics, I've used these books. Okay. And one thing I'll say too is that I always tell people don't pay full price for a textbook. So I still remember what it's like to be a student and how much money I wasted on, well, not wasted, that's not a good word. How much money I spent on textbooks that may not have been that important to me. And you may think that Professor Tran, you were a student such a long time ago, right? So you were a student over 15 years ago. But you'd be surprised. I hold grudges for a very, very long time. And so, I still remember when I was applying for grad school, there was a professor at UCI who invited me to come tour his lab because he wanted to recruit me to join his lab. And he said like, oh yeah, you can come to campus and you can park anywhere. They don't check parking on campus. So I go there, I check out his lab. His work seems interesting, and I come back and I get a $65 parking ticket from UCI. And so I still remember that, and that's why I never ended up working for that. And in fact, one thing I even did was that afterwards I looked up, I saw that he published a textbook, and I pirated his textbook. But I think of it as I paid for it already because I paid UCI $65. So anyway, so that was a completely unrelated story. But if you do want to pick up one of these textbooks, be resourceful. Okay, course website. So the course website we use is Canvas. That is the university mandated course website. Canvas is fine. I think it kind of does everything that you need to. So I post everything that you guys need onto Canvas. So all the lecture notes, the lecture slides, homework assignments, solutions, study guides, and just basically any content that I produce for this class will be on Canvas. I do record the lectures as well. So I know probably some of you guys know that already just because you've had me before. But you can find all the lecture recordings on Canvas as well. So I upload them to YouTube and I put the links to YouTube on the Canvas site. Okay. I will also use Canvas as kind of the primary way to communicate with the entire class. And so, I basically will make announcements on Canvas. And the Canvas, I think, emailed all of you. At the very least, it emails me. So I assume that it emails you guys as well. Of course, if I need to contact you guys individually, I'll probably email you. But, whenever I email the entire class, I will use the announcements feature on Canvas. Okay. And all of the Zoom links for attending the lecture and office hours are on Canvas as well. Okay. One thing about Zoom as well, and and I know some people have figured it out already just because they're on Zoom. But I am streaming these lectures on Zoom. I don't mind if you guys attend on Zoom. The only days that I require you guys to be here in person are the exam days, and so please make sure you're here for that. All other days you guys are welcome to attend on Zoom. And I think that's especially useful for grad students just because I know you guys are working. I know some of you guys have been doing long commutes. And so if it's more convenient for you guys to, watch the lectures from your homes, then please do that. Okay. I don't recommend driving while listening to the lectures. That's usually a very easy way to get into a car accident. But when you're at home and you're able to take notes, that's a good way to do it. Okay. And if you are going to be watching the recordings, generally I recommend that you watch my videos at 1.0 speed. I kind of optimize my voice so that that's the kind of the best speed for, taking in information. I wouldn't recommend 1.5 just because otherwise it'd be a little bit too fast. Okay, policies. All right, so late homeworks. And so I do accept late homeworks. And so if you don't make it by the deadline, that's fine. So you have a week after its original due date to submit it. But keep in mind that each day that the homework is late, I will dock 10% from the class. Okay. And if for some reason the Canvas site isn't working, and this is true even if you turn in the homework on time, right? So if for some reason you can't turn it in on Canvas, you can always scan your homework assignments and email it to me as well. So I'm perfectly fine accepting it that way. Thankfully, there's not too many people. There's not too many of you guys in this class, and so it's easier to keep track. Okay. Regrades, and so for homeworks, probably not as relevant for this class. Just I grade you guys on completion. But if you ever want me to take a look at your exams and you want to discuss, maybe I kind of graded you guys too harshly. I'm always open to that, right? So please, the only requirement that I have for regrades is that you make the request up to a week after I return whatever graded assignment to you guys. Okay. So let's say that you guys take an exam. Usually after an exam, it takes me about a week to grade it. So, you take an exam on a Wednesday, I'll return it to you guys the next Wednesday, and then you have until the Wednesday after that to request a regrade. Okay. The reason for that is that, when I do grade, especially when I grade your exams, I am going to be leaving comments just to kind of give you guys feedback. And I do want you guys to read those comments because if you kind of wait until the end of the semester and you realize, hey, I need a few extra points, those comments are not as useful to you guys. And so I do want you guys to kind of look at your grades. Kind of seems like an obvious thing, but sometimes you'd be kind of surprised at what people do. So I do want you guys to look at those kind of sooner rather than later. Okay, emails. So if you are going to be emailing me about this class, I do ask that you include EGME 520 in the subject line. So there's not too many of you guys in this class, but I am teaching 2 undergraduate classes that have 50 students each. And so I do have a lot of students this semester. And so it does kind of help me kind of sort through my inbox if you include EGME 520 in the subject line. At least until I get to know you, then I kind of know who grad students are. Okay. And usually with emails, I'm pretty fast. This week I may be a little bit slow just because there's kind of a lot to do with advising. But usually I'll get back to you guys within 48 hours of business time. Okay. Okay. Any questions on course policies? Okay. Okay. Academic dishonesty. So don't have to spend too much time on this. You guys are grad students, but academic dishonesty will not be tolerated in this course, and so that includes any kind of plagiarism that you guys are going to be doing as well as ChatGPT. Okay. And I would say for this class, probably not as big a concern just because, most of your grades are going to be based on the exams, but, it's worth kind of talking about. Okay. And the way I see it is that, I always say that, AI is a great tool for productivity. Okay. So if you need to produce something, AI kind of, shortcuts them out of the work for you. Okay. And so if we were doing this class, if you're doing the work for this class, and if ultimately that was going to be a product that we're going to sell, then I would say, by all means, there's no harm in using AI. But taking a class and doing work for a class like this is kind of fundamentally different than doing work for your job, right? I'm not going to be taking your guys' work, your exams and homework or anything like that, and we're not going to be using that to produce any profit, okay? The value in taking a class and doing the things for a class is for you guys to do it and learn the knowledge and skills from that. And so if you have something else do the work for you, whether it be your homework assignments or maybe for a project for another class, it kind of defeats the whole purpose of taking the class, and it kind of just ends up being just a waste of time and money for everybody. And so that's why I do have a very strict policy with regard to AI. I know it's kind of a hot topic in higher ed right now, and so I do I just say no AI at all. Okay. And I know a lot of times, when you are tempted to kind of use these kind of tools, a lot of times it comes from, maybe not a malicious point of view, but maybe you just feel like you're really struggling in the class, or, maybe you're struggling to keep up. What I always tell people is that, my job here as your instructor is to help you guys learning as much as I can. So if you guys ever feel like that you're struggling in the class, or ever feel like that you're struggling to keep up, just please reach out to me, and I promise you I will do everything I can to help you guys, get caught up and get you to a place where you need to be. Okay. Whether that be, having extra office hours to kind of explain things for you, or to give you guys extra practice problems, give you more practice for the exams. I've recorded, midterm review sessions as well. I know people that have been helpful for people in the past. And so if that's something that can be helpful, I'm always happy to do that. But just please reach out to me, because, by doing so, I can help you guys kind of get to where you need to be, right? I'm not going to give you the answers right away a lot of times, because I do want to encourage you guys to kind of engage with the content, because that's you ask an AI, the AI is just going to give you the answer. But my goal is for everyone to succeed in this class and to get the skills and the knowledge they need, that you can use to take to your next thing, whether that be maybe you're working on a research project that involves viscous fluid flow, or maybe you're going to be using it for your job. Right. I want you guys to be able to take this class and say, like, yeah, I learned something useful from this class. I learned something valuable. This was not just a waste of time. This was not just, something I just checked it once. Okay. Okay. Last thing. So the first, not real homework assignment, but you are getting points for it, is email introduction, right? So this is homework 0. So, we're going to be spending the next 16 weeks together. And so, it's a lot of time for me just to be kind of standing up here, just talking at you guys. And so, I do like to get to know you. So, first assignment is for you to just send me an email and introduce yourself, right? And you get full credit just by completing it, because, I mean, I know this class, I grade everything based on completion, but, it's not like I can grade your introduction, right? I can't say that, no, that doesn't sound like you. I'm going to mark your points off. So, just send me an email, and, you're free to write as much or as little as you want. There's really no guidelines for this. I have these 4 questions here, but they're really only there just in case you don't really know where to start. And so, feel free to answer these questions, but, you can talk about whatever that you want in your email. Okay. So just make sure you include your name, just so I can give you credit. I know it says in the subject line, but, it helps to have your name. And just send me an email to introduce yourself. Okay. And so that's due this Friday, August 28th. And so please make sure you get it to me in time. Just so that you get full credit. Okay, I will read through every single one, and I do respond to every single one. And I promise you, I'm not running this through ChatGPT. I'm reading every single one and typing out every single response. If you write me an essay, I will respond with, maybe not an essay, but maybe like half an essay, just because I have a lot of students. But I do really enjoy reading these, and kind of the more that you write, kind of the more enjoyable it is. Okay, I've had people kind of send me pictures of their pets. I always enjoy that. I have 2 cats, so I love seeing pet pictures. Your hobbies, what are your goals, things like that. Okay. All right, and so that's it for the slides. And so we're at about 7:35. So next thing I'm going to do is we'll go through the course website for maybe the next 10 minutes, and then we'll probably spend the last half hour just lecturing, or just starting the lecture, so that we can pick it up on Wednesday. Okay. Any questions on just anything that I talked about with regards to the syllabus or the course policies? Okay, all right. So let's quickly go through the Canvas site. So again, I know quite a few of you guys have had me before, and it's not on my course website. It's complicated. I try actually very hard to make it very simple, or clean, I guess you can say. It's very clean, but it's worth kind of taking a tour anyway. Okay. Okay. So when you log on to the Canvas site, this is what you'll see, right? So this is the kind of the custom homepage that I made for this class. I say it's custom, but there's really not much to it. But you can see that there is the name of the course, 520 Advanced Viscous Fluid Flow. There's me. That's my email address in case you forget. Class times, Monday, Wednesday, 7 to 8:15 p.m. Everyone here knows that because they are here. And the location is EC 121, which is this room here. But of course, you guys are welcome to attend on Zoom, right? I can't officially say that this course is hybrid just because honestly the paperwork is kind of a hassle to go through. And so I just post a Zoom link and then I just don't tell anybody. But you guys are free to go on Zoom. But officially, the location, at least in terms of the registrar, is EC 121, which is this room. Okay. Here we have a description of the course. This is just lifted straight from the syllabus. So I wrote this, many years ago. Here are the course level learning objectives. Okay. Here we have a link to the syllabus. And so, this PDF here has kind of everything that we talked about. We just kind of went all over it here. But you can definitely look at this for reference later on. Okay. Here are the Zoom links. And so we have the Zoom link for the lecture. Zoom links for the office hours. All the office hours are actually the same Zoom link, but I just list them all here just so that you guys remember the times and days that they're available. Okay. All right, and then finally, the thing at the bottom here is the course outline. So you can see week by week here, this is the kind of the plan that we have here for the class. Okay. So as we kind of go through the semester, each of these lines here, each of these boxes will become clickable. So right now, only week 1 is clickable just because we're only in week 1 right now. Okay. And if you go to these weekly pages, you'll see that they all kind of have the same format, right? And so there's the title for the week in terms of what we're going to cover. There's a little blurb there, right? It's kind of the last thing that I do on Friday. So some of them, sometimes they make sense. Sometimes they may be a little bit rambling. Okay. We have the learning objectives for the week, right? Here is where you're going to find the lecture recordings. And so I sort them out per week, right? So each week we have, usually 2 lectures. And so lecture 1, lecture 2. So as soon as this lecture is over, probably tomorrow morning, just because it'll be kind of late after the lecture, but I'll upload the lecture onto YouTube and then put the link here. Okay. Any assignments that are due that week will be here as well. So right now we just have homework 0, which is the introductions, and just any of the files that you need for that week as well. So all the lecture notes for the week I'll have posted here. Any kind of study guide or solutions that I create will be here as well. Okay. So I always recommend to people, I try to get these up by Friday the week before. And so, take a look at these, download any file that you need, take note of any deadlines that are coming up. At the very least, check this at the beginning of the week, okay? Because this is kind of everything that you need for the week that's upcoming, okay? Okay, so that's the home page and the weekly page. And so, make sure you guys are kind of staying up to date on that. Next tab here is we have announcements. And so, you probably aren't going to come here that often just because all the announcements are emailed to you guys automatically. But for some reason, if you wanted to see a historical look at all of the announcements, that's here. Okay. I try not to email you guys too much just because I know you guys get plenty of emails and honestly spam from the university. So, I'll probably send maybe 5 to 6 announcements throughout the entire semester. But you can kind of look at all of them here. Okay. Next, we have the assignments tab. And so, this is all of the assignments that we have upcoming. So right now, the only one I have activated is homework 0. I will post the first problem set before the end of the week. It just, doesn't make sense to have the first homework assignment problem set before we have the lectures. Okay. But, you can check the assignments here, and this will tell you when it is due. Okay. Next tab here is the grades, right? And so these are all of the, once we kind of start having assignments and we put them in here, this will show you your current grade. Here is the breakdown of the grade totals, okay? Right, and so this is kind of what we talked about in the lecture. Okay. Next tab is people, and so this has all the people that are in this class, and so it's a fairly short list. Just again, there's not too many of you guys in here, but this is all of the all the people in the class. Next tab here is we have files, right? And so any any files or any documents or any study guides that I post for the class will be in this kind of folder here. I will be posting any files within the weekly pages, but for some reason, let's say that you're looking for a very specific file. You can come to this files tab and look for it, okay? But, if you're kind of keeping up week by week and kind of downloading the files as I kind of post them per week, I think most people don't come here, but, if you do need a specific file, you can find it here, okay? Okay, next tab is SOQs, and so this is not activated until the end of the semester, right? And so you can't give me a 1-star review right now. You have to wait until after Thanksgiving to give me a bad review. Okay, but when this is activated, you can do that here. And this is a new tab here. So this is a tab for student resources. And so normally I would deactivate something like this just because there's a lot of just clutter on Canvas, honestly. It's like, buying a new phone and there's a bunch of bloatware. I feel that way with Canvas, but this one's actually pretty nice, right? And so this is a link to, a bunch of really good services that are available at Cal State Fullerton that honestly not everyone takes advantage of, right? And so you have mental health services here. We have links to the academic integrity policy, DSS if you need to request accommodations, Office for Civil Rights and Equity, and Compass, which I don't know what that is, but I'm sure it's useful, right? And so if you ever need a link to useful kind of campus resources, then this is kind of gives you that link to. Okay, all right. So I have a pretty straightforward course website. You're not going to be interacting with it, besides just downloading files every now and then. But all that is there for you guys. Okay. All right. Any questions on the Canvas website? Okay. All right. So let's so that's everything with the introduction. So it's okay. Normally I would stop here for the first day, but just because we are losing some days for holidays, let's lecture for at least 30 minutes, and then I'll let you guys go. Okay, and so this will kind of give you a chance to see kind of how I normally operate as well. So, I usually don't like slides just because, what tends to happen from lecture slides, and this is my own fault just because I just like to yap, but I just kind of end up just talking just kind of endlessly. But, when I have my iPad here, I at least take some breaks to kind of catch my breath and kind of, write stuff. And so this is kind of typically how I'll lecture, okay? So usually, when you come to class each day, I usually try to get here at least 15 minutes early before the class. I will write down all of the learning objectives for the day for you to write down, okay? Okay, so let me, my voice actually does need a little bit of a break. So let's take a couple minute break. So let's come back at 7:45 and then we'll start the lecture. But I'll leave the learning objectives here for you guys to write down in the meantime. Okay. Okay, 7:45. Sorry. I think it's just really hot too. I think it's just hard to stand up here and talk when it's so hot. I heard the air conditionings are kind of kind of struggling a little bit just because they connected the new dorm buildings to the same AC line as these buildings. And so AC is not coming out as strong as it could be. It does help that we're at night, but, I still kind of feel like I'm up here, just kind of broiling up here. But okay. All right. So let's go ahead and get started. So again, this set of lecture notes normally is, reserved for day 2. So you're going to see a little bit of repeat information from the introductory slides. But the idea with these lecture notes is kind of give a little bit more detailed introduction to the course. Okay. All right, as well as kind of providing a little bit of a refresher from your introductory fluids class that you probably took as an undergrad. Okay, so let's go introduction to viscous flow. Okay, so like I mentioned in our introductory slide, viscous flow is a kind of a subspecialty or kind of a subdomain of fluid mechanics in general. So, one thing you'll see, and so if this is your first graduate level course, I think what you'll see is that in general, graduate level courses, and take this with a grain of salt. This is something I feel just because I've been doing this for years. I don't necessarily think that graduate level courses are harder than undergraduate courses, but they are more in depth and they are more specialized. Okay, and so instead of taking a course on fluid mechanics in general, you're taking a course that's in one very specific area of fluid mechanics. Okay, so that being viscous fluid. Okay. Okay. Right. And so viscous flow, just kind of the name implies, is a subdomain of fluid mechanics where viscosity plays a major role. Okay. Now that statement is actually very interesting because viscosity is something that hopefully should have been covered in your introductory fluids class. But if you actually look at the overall list of topics in your introductory fluids class, you actually don't do too much with viscosity, right? So typically for a traditional fluids class, and I know this just because I just taught it over summer, right? Viscosity is kind of introduced as a concept kind of early on in the class when you're kind of talking about fluid properties in general. You talk about, hey, there are some fluids that are very viscous. You think of honey, you think of molasses. But then when you actually get to the theory, a lot of times you say that, oh, we're going to ignore viscosity because it makes things very complicated, right? So you think of things like your Bernoulli's equation, think of things like your think of things like your potential flow theory, your stream functions, things like that. Okay. So all of those topics, we kind of teach you guys to ignore viscosity because things get more complicated. Okay. Well, now you're in grad school, so now we're going to be talking about those more complicated things. Okay. So let's kind of talk about viscosity in general and kind of what and the effects that the general effects that it has on fluids. Okay. Okay. So I think kind of the first definition that you'll get for viscosity in your general fluids class is that viscosity is a fluid's ability to resist flow, right? Fluids that are more viscous than others will resist flowing more so than others, okay? Because flow, that's generally the thing that separates a liquid or a fluid from a solid, right? So solids don't flow, right? So I can take this phone, right? And you hold it upside down. As long as I'm holding onto it, the phone is not going to be going anywhere because it's not flowing, right? But if I took a water bottle and turned it upside down, right, we expect the water to come out and for there to be a mess to clean up, okay? But for fluids that are more viscous, they're going to have a harder time flowing than others, okay? Okay, and so this is important because remember, fluids in general, right? What separates a fluid, and by fluids, I'm kind of grouping in liquids and gases, is that they have the ability to continuously deform when applied or when undergoing some stress. And so if we say that flow is a very characteristic property of fluids, while viscosity is kind of the ability for the fluids to resist flow, right? You can see how different levels of viscosity are going to play a big role in terms of how that fluid is going to behave in general. Okay. So this class is going to look at all of those different situations and how they affect things. Okay. Okay. And so as we kind of go through the different properties, and that's kind of the purpose of today is to kind of go through all the different properties that fluids can have, right? I do want to mention something that and typically this is gone over kind of a bit more in detail in an undergraduate fluids class. But let's talk about the continuum assumption. Okay. Okay. And I think and this is kind of the way I interpret it. The continuum assumption, I think, is part of the reason why I think a lot of people really struggle learning fluid mechanics, just because, up until that point, everything that you've learned in terms of physics and mechanics does not hold the continuum assumption. And, there's oftentimes not a lot of time that's spent at that level to describe kind of what that actually means. Right? So what does the continuum assumption mean? So when we look at a fluid, we don't look at the fluid in terms of individual particles, or kind of more specifically, we don't think of a fluid as a fixed amount of mass. Okay. Okay. That's very different from how you analyze solids, right? So when you do an analysis on a solid object, so let's say you're doing an analysis on like a chair, or you're doing analysis on like a bridge, usually there's a fixed amount of mass within that object that you are studying, right? So your bridge has a fixed amount of material in it. Okay. Fluids are studied very differently, right? Because remember, fluids are continuously deforming. And so, if you were to try to study a fixed amount of fluid as it flows in a very complex system, you just wouldn't be able to do it. It's just not a practical way to study fluids. Okay. Okay. So let me visualize that for you, right? So let's say that we have flow in a pipe. Okay. So flow is going this way. And so if we were to analyze this pipe flow kind of in the traditional way that we would normally do a solid mechanics type analysis, we would identify kind of a fixed amount of fluid, right? So let's say that we draw blocks here. right? So let's say that, we want to analyze this amount of fluid here, right? So, we want to track its motion, we want to track its position, we want to track its acceleration, right? That's typically how we do a solid mechanics type of analysis, okay, or dynamics analysis. Okay. Right? Because that's typically how we do solid analysis, right? We take a fixed amount of solid and we track its rigid body motion. If it has any kind of elastic deformation, we can do that kind of very easily as well because the amount of mass is fixed. Okay. But with the fluid, that's very difficult, right? So even if you take a snapshot in time, right? So even if you take a snapshot in a pipe and say that we want to analyze this fixed amount of fluid, right? As soon as you look at that fixed amount of fluid, even just 1 second later, the situation gets very, very complicated, right? And we're not even talking about situations where the pipe is going to be branching off. That was actually what I was going to do. But even if you look at just a fixed amount, even if you just look at a single pipe going in a single direction, you'll see that the problem gets very complicated very quickly, right? So let's say that we try to track this fixed amount of fluid, and we look at this fixed amount of fluid maybe just 3 seconds later. Okay, so not even that much, not even that much amount of time. You would think that in 3 seconds, not much can happen, but when you have a fluid that's constantly moving, right, you're going to see that that fixed amount of fluid there. If we were to track the exact particles that we had started with, it gets complicated. Okay, so let me draw the pipe again. Because one thing that you'll see that when viscosity plays a role in fluids, you have these what's called a velocity profile. So different locations within your domain, the fluid is going to be moving at different speeds. Okay. And intuitively that makes sense, right? Because if you look at flow in a pipe, where do we expect the speed to be highest in a pipe? It's going to be near the middle of the pipe, right? So as you kind of get closer and closer to the walls, the flow tends to kind of slow down. Okay. And so if you were to try to track that fixed amount of fluid, right, you're not looking at a rectangle anymore. You're looking at maybe something that looks like this. Okay. Right. So that shape that I drew there, that kind of looks like Ryu doing kind of a Hadoken, right? That's the same amount of fluid, the same fixed mass that we had started with. It's just that the shape of that fixed mass has deformed because different layers or different regions within that box are moving at different speeds. Okay. Right? And of course, if you wait even longer, right? So let's say that you wait 10 seconds later or 20 seconds later, right? That fixed amount of mass that we started with has now been kind of scattered all for, in all different kinds of places, right? You can't really make a statement in terms of, what's the position of this fixed mass or what's the velocity, what's the acceleration, right? Because none of that really makes sense when your mass is, traveling and moving at very different speeds, okay? So we don't adopt that. Okay. So instead, when we study fluids, we take the continuum assumption, right? Where instead of looking at a fixed amount of mass, we're instead looking at the fluid properties at different positions within the flow. Okay. And so instead of kind of basing our analysis in terms of, where is this mass, where is this fluid mass going? We're instead looking at a location-based analysis, right? So if we look at a one fixed location, we kind of plant the flag down, right? We're going to look at all the fluid properties that pass this specific location and then track that as a function of time. Okay. Okay. So for instance, right? So let's take a kind of a pipe that looks like this. Okay. So I'm going to exaggerate this just to kind of illustrate a point about this, but where I draw these dots kind of has no significance really, right? And so you can assume that where there are millions and millions and millions of these dots kind of placed everywhere. Okay, but the continuum assumption, we're looking at a situation that looks maybe something like this. Okay. Right. So we're drawing all these little dots, right? And then for each of these little dots, we're going to observe the fluid properties, things like velocity, things like density, vorticity, viscosity of the fluid as they go past this these markers. Okay. Right. And so again, there's no significance to where I drew those dots, right? And so you can draw dots all throughout the domain. Okay. And so what you're going to see is that when we kind of analyze and when we kind of produce fluid properties, they are going to be functions of space and oftentimes functions of time as well. Okay. Right. And so for instance, right, so each of these dots here has a location, right? And so let's say that we want to plot the velocity, right? So each of these markers, you can think of them as like a probe. Each of them are probing the velocity of the fluid as it's moving past. Okay. Right. And so, maybe we have something that looks like this. Okay. Right. So each probe in this case, so I'm just using velocity just as an example, but you can think of any fluid property and you can think of its observation as a function of space. Okay. Okay. Right? So each of our probes here knows its location, right? And each of those probes knows what the fluid property is there as a function of time. Okay. So as a result, right? As a result, basically every fluid property here we can express as what's known as a field quantity and something that is a function of space, right? So a function of x, y, sometimes z, right? So we won't go 3D too much in this class, but usually at the very least x and y, as well as time. All of that is kind of a very roundabout way of saying that we are going to be doing a lot of multivariable calculus. Okay, so we're going to be looking at functions and parameters that are functions of multiple variables, right? So x, y, z, time, things like that. Okay. Right. So velocity, right? So velocity is going to be a function of x, y, z, and time. Okay. Acceleration, right? Acceleration is going to be a function of x, y, z, and time. Okay. Right. Where x, y, and z, those you can think of those as the locations of the probes. Time is going to be how the property kind of changes with time. Okay. Pressure, I always forget pressure for some reason, right? Pressure is a scalar quantity, but pressure also can be a function of x, y, z, and time. Okay, that's just to name a few, but there are a bunch of other fluid properties that we're going to be going over in this class as well. Okay, so I wanted to go over that just because the continuum assumption, again, it is something that's covered in your introductory fluids class, but in this class it's going to play an even more important role because a lot of the theory, a lot of the concepts that we're going to be going over in this class, kind of assumes that you kind of have this understanding. Okay, so fluids, we don't analyze it in the traditional way that solids do. We're not tracking fixed amounts of fluids just because it's just impractical. But instead, we take this kind of location-based, continuum assumption, field-based approach to analyzing fluids. Okay, and then as we kind of develop the equations, this is the assumption that we're going to. All right, any questions on this so far? Okay, good. Okay, so what we're going to do next, and obviously we're not going to finish everything today, is I do want to take a survey or do a survey of all the different fluid properties. Sorry, maybe not the best wording I could have done. I'm not going to survey you guys anything, but we're going to go through all the important fluid properties. So think of this as kind of a very quick kind of just rapid fire review of fluid mechanics. Okay. Okay. And you'll see that there's quite a few of these, right? And so there are some that are material properties, so things like density, things like viscosity. So those are properties of the fluid material. Okay. Some are field properties, and so depending on the state of the flow, these are the properties that we have. Okay. Okay. So first one, probably the most straightforward one, but also probably the one that's most important to know is velocity. So velocity, pretty straightforward. It's a concept that you've learned ever since physics 1. Velocity characterizes the speed of the flowing fluid. Okay. Right. And so just like we just finished saying that, so the velocity is typically expressed as a field quantity because of the continuum assumption. Okay. So being a field quantity means that it is a function of multiple variables, right? So at the very least at least two spatial variables, sometimes time, right? So we probably won't do unsteady flows until maybe the middle of the semester, just because things do get a bit complicated with unsteady. But at the very least, you can have two spatial variables. Okay. Okay. So we've already talked a lot about the continuum assumption. So there's not too much more to talk about with velocity. But again, generally speaking, when viscosity is playing a role, generally your velocities are going to have a very high amount of variation, right? And so the velocity at one location may be very different from the velocity at a different location. Okay. So that's one thing that, I think you'll see that's quite different about viscous fluid flow compared to, inviscid fluid flow, where you ignore viscosity, is that you do have these very large variations in velocity, okay? That's part of the effect that viscosity has, that, it causes these velocities to be quite different. Okay. One other point that I'll make here, kind of an obvious point, but it bears mentioning, is that fluids with higher velocity will have higher kinetic energy. Okay. Okay. So velocity is a quantity that we'll be going over. You'll be seeing this on a weekly basis, right? Just because it has a very intricate kind of relationship with viscosity. But so just get used to saying velocity. Okay. Okay. After velocity is acceleration. That's kind of the next logical step. Okay. And so acceleration, it has the same definition of fluids as it does in solid mechanics. Acceleration characterizes the rate of change of velocity with respect to time. All right, so normally in order to get acceleration from the velocity, just take the derivative with respect to time, okay? That's true here as well, but when you have a flowing fluid, or I guess, more specifically, when you take the continuum assumption, you have to also account for the fact that velocity can also change when you flow from one location to another, right? So just by nature, just going from one location to another in a flowing fluid, your velocity can change as well. And we have to account for that in the acceleration. Okay? Right. And so with this kind of effect here, basically a change in space, right? So a change in location affecting a change in velocity. This introduces a new type of derivative called the material derivative. Okay. So I'm going to state the material derivative, and then we will end here for today, and then kind of start our discussion on Wednesday with that. Okay. So the material derivative, which we're not only going to use for acceleration, this is something that we'll see for other quantities as well, something like this. Okay, so the material derivative, we usually use capital D's for. So we have capital D U, where U here, it can be a velocity, it can be something else with respect to time. Okay. Right, so one part of the material derivative is the partial derivative with respect to time. So that right there is kind of our traditional acceleration term. Okay. Okay. So we have one term there that is just a partial derivative with respect to time. But then we also have terms here that basically account for the fact that properties can change with the moving fluid as well in space. Okay. So you have u partial x plus v partial u partial y plus w partial u partial z. Okay. Where these collection of terms here are known as the convective terms. Okay. and they represent changes with the moving fluid. Okay. Okay. All right. So let's end here for today. It's 8:15. It's already late. When we come back on Wednesday, we'll kind of pick up right where we left off here. So we'll talk a bit more about the material derivative. We'll talk a bit more about the significance of the convective terms, because that is something that's going to be important for this class as well. And then we'll continue our survey of the different fluid properties. Okay. All right. So thank you guys for coming today. It was great meeting you all today. If you have any questions about anything, I'll stick around a bit after class. Feel free to send me an email as well. And I hope you guys have a good rest of your evening, and I will see you all on Wednesday.
Probably, but
See you, James. I submitted the abstracts today, so you should get the permit sometime this week. Probably tomorrow. Yeah. Yeah. Hey guys.
I have a question about the requirements to graduate regarding the project thesis.
Okay.
Dr. Didn't really get back to me.
Okay. Yeah. Over summer, it's always hard, just because.
Yeah.
So if you want to do a project or thesis, you do need a faculty advisor for that. So you need to reach out to a faculty that you want to work together with. I heard that Dr. James is accepting students, but he's honestly really busy right now. It's gonna be really hard for him to advise. And so I would reach out to other faculty and see who's willing to take students right now. Because usually some faculty will have a project that they need a student on. So yeah, I would reach out to them and see who's looking for students right now. And usually it's a 1 year time frame. So if you start this semester, then you're probably going to be finishing up a year from now.
It hasn't really been clear to me about the whole project or thesis. Can it be like something that you wanted to specifically like?
You could. So some faculty are willing to work with the student for, if you have a project idea that you want to work on, and the faculty can provide you mostly with just the resources and guidance. And so some faculty are open to that as well. You just kind of have to talk to people and see what they could.
Could it also be for a professor outside of the department?
It could. It's not traditional, but it can definitely can be. You'll probably need an advisor that's in the department, at least just to sign the papers for you.
Okay.
But if you're going to be primarily working with the faculty outside, then we're open to that as well.
Yeah, that's interesting. So this is my second year. That means I have to get started right now.
Yeah. So if you're planning to graduate spring 27, then you need to start now, because you need to do the project, get the data and present it and defend by end of spring semester.
Okay. So my options there are to find a professor then. So either I do work with them of their own research, or I have my own project or thesis.
Exactly. Yeah.
Okay.
Yeah. Send me an email just because I'm gonna forget. I'll send you the abstract form from it. And so basically what we need you to do is to have an abstract for the project that you're gonna work on. It needs to be approved by the department, and then that way you can get a permit to enroll in either 597 or 5.
Okay, because I was looking at those classes and it looked like it was something a capacity of like 1.
Oh, so the way we do it is that once the abstract is accepted, then we basically add you to that class. We give you a permit.
Oh, okay.
Yeah, so it's not something you enroll in traditionally. It's something we create once you have a project. Yeah, so don't worry about the capacity. Yeah, once you have a permit, then we'll create that for you.
Okay, awesome. Thank you.
Yeah.
Do you know what the deadline is to submit like the abstract or whatever for the thesis?
It is end of second, so end of next week.
So I'm doing a little bit of work with MyRL.
Okay.
And I was hoping maybe I'll probably reach out to you when we're a little bit closer to finishing up like our proposal for the
Okay.
thesis.
Yeah. I'm working with a couple students of his. Normally he would sign the papers, but he doesn't work here anymore.
Yeah.
So I've been signing the papers for his students. So that's actually a great example of that. So they're working with the faculty that man, you probably know Dr. Merrill. So he works at UC Riverside now. He's still continuing to advise our students here, but I'm serving as kind of the on-campus person that just signs the papers for him. But he's doing most of the advising himself.
And so if we do like what are the requirements of like this project or this thesis that we have to work on? What does it have to be?
It's so in terms of scope, it's very open. I wouldn't say there's probably no guidelines in terms of that, but it has to be something worthwhile, which is a terrible way to put it because that's such a loaded phrase. But you should be able to produce something at the end that either demonstrates that you're going to be learning a skill that you don't learn in the classroom, or if you're doing like a thesis, you should be able to produce some data or some kind of conclusion that kind of contributes to the greater scientific community. In terms of the deliverables, there's only two actually. So you need to submit a final report. So that's something that you're going to submit at the end of, well, if you're going to plan to finish the spring, it'll be at the end of the spring semester. And then there's also a final presentation. So the final presentation is you're going to get a committee of faculty together. One of them is going to be your advisor, and then usually you pick two others, and then you present your work to them, and then they ask you questions and give you feedback. But usually by the time, so I would say most faculty in our department are usually pretty good about this. We typically call it, some people call their final presentation like a defense, but it's, you're not really defending anything because, usually by that point you've been working closely with your advisor. So the project itself is good. It's more just kind of presenting it and kind of, getting some last minute feedback.
So for the deliverables, you said it was like a report and a presentation.
Yes.
If I want to do something like create something, how would that work out?
It would still be the same deliverables. So I know people that work with Dr. Robson, they've made like kind of robotic prototypes. And so you still would have to write the report and still make a presentation. It's just that, you would just collect the data on just whatever or something that you create.
Yeah, because I don't know, I was supposed to have also to think about it, but it just spends at work, I don't know.
Yeah, it's easy because it's something that like you know that you have to put a lot of time into, but also it's like where do you even start to think about a project?
So just this degree is like too broad, but like I don't know what's
exactly. Yeah. I would definitely talk with faculty and see, and then just send me an email just so I can give you the form. See what they're working on and see if they have need for students right now. You'd be surprised, and so some faculty may not. I would be honest. Some faculty probably won't get back to you, but some faculty go, oh, this is perfect. I'm looking for a student to work on this project. Or maybe if you pitch an idea to them, so like say you have an idea for a project, they say, oh yeah, that sounds really interesting. I'd love to be a mentor for you or advisor. So yeah.
Thank you.
Yeah, no problem.
All right. See you Wednesday, Dr. Charles.
Yeah, see you guys. Have a good night.